This is part 5 of section 8.4. We have a savings account that has a rate of 6%. We're asked to find the effective annual yield, rounded to the nearest tenth of a percent, if the interest is compounded first quarterly and then daily. So we're going to be using this formula here. The first thing I'm going to do is I'm going to write down the formula, putting in the parts that are going to be the same for both calculations. So we're looking for the yield, and that is going to be 1 plus our rate, which is 0.06 over n, that's the part that's going to be changing, raised to the nth power, and then subtract 1. So for our first calculation, quarterly, that means our n value is 4. And we just need to plug everything in. So our yield would be 1 plus 0.06 divided by 4, raised to the 4th power, and then we're going to subtract 1. So I have 0.06 divided by 4, add 1, raise that to the 4th power, and then subtract 1. And we have our rate written as a decimal. So this would be, move the decimal place over 2, or if you prefer, multiply by 100 so you can see it. We're supposed to round to the nearest tenth. That's going to say 1. So this is 6.1% yield. Let's do the same thing for part B, but this time 360 times. Our n is 360. So the yield is 1 plus 0.06 divided by 360, raised to 360, and then subtract 1. So 0.06 divided by 360 plus 1, raise that to the 360th power, and then subtract 1. And we have this, and we want to convert it to a percentage, so either move your decimal place or multiply by 100. We're supposed to round to the nearest tenth. That's an 8, so that's going to become a 2. This is 6.2% yield. Okay, same type of problem. We want to determine the effective annual yield for each investment. Then we want to figure out which is the better one. Assume 360 days in a year, round to the nearest tenth of a percent if necessary. So we have, this is the type of thing I was talking about. We have two different rates and 2 different compounding periods. This is a lower rate, but compounded more often. Higher rate, less often. It's hard to tell just by looking to figure out which of these is going to be better. So I'm going to find the yield for each of these. The yield is equal to 1 plus r over n. Our rate is going to be 0.05, compounded monthly, so my n value is 12. And this is raised to the 12th power, and then subtract 1. And subtract 1. That's our rate as a decimal. Let's multiply by 100 and round to the nearest tenth. So this is about 5.1% yield. Okay, now we're going to do the same thing with a different rate, compounded quarterly this time. So our yield is 1 plus 0.0525. Quarterly would be 4, so over 4 to the 4th power, and then subtract 1. So and then I'm going to multiply by 100, and we get about 5.4% yield. So these are our 2 investments, and This is equivalent to a simple interest rate of 5.1%. This is equivalent to a simple interest rate of 5.4%. And if you are investing, this is the one you want because you're going to make more money off of that eventually. Now, these are talking about investments. If it's reversed and you're taking out a loan, we call this APR, annual percentage rate. It's the same idea. So if you're going to go buy a car, you want the lowest APR because that's going to be your better financing deal. Same type of problem, but we have 7% compounded annually and 6.85% compounded daily. Okay, so our yield is 1 plus our rate, 0.07, over the number of times we're compounding. Annually would be 1. This is n equal to 1. So this is raised to the first power, and we subtract off 1. Well, this is about as easy as it's going to get. If we raise that to the first power and subtract 1, we get 0.07, which is 7%. Compounded annually, that's basically the same as simple interest if you're only doing it for 1 year. Now let's do this one, lower rate, but much more often. Our yield is 1 plus 0.0685 over daily, which is 360. And this is raised to the 360, and then subtract 1. So so 360 minus 1 times 100 to get the percent, and we want to round to the nearest tenth. So this is about a 7.1% yield. So which of these is better? That one.